Good morning. Let's talk comparing linear functions this morning. I am looking at three functions. F of x, g of x, and h of x is how we name the three functions and differentiate between the three functions. When a function is linear, as in this example, there are two values needed to write an algebraic model of the function in slope-intercept form. Those are the two values we use to compare linear functions because those are the two values that tell us everything we need to know about that line. So what are those two values that are needed to write an algebraic model of the function in slope-intercept form? What are they? What is slope-intercept form? That's really the equation you need to remember when you think of linear functions. When I think of linear functions, I think of the slope-intercept formula, which is, let's review. So those two things we need to know, slope, aka rate of change. You'll also learn later we use slope as an average rate of change even when we're looking at nonlinear functions, but slope is the first one. And then we have the Y-intercept. So slope-intercept formula is pretty telling in the name because we've got slope, but then the intercept is specifically the Y-intercept, the initial value, that starting amount in the problem. And it's always represented with x equals 0 and some value for y because it's where it crosses the y-axis, the vertical axis. So the y-intercept tells us where we are starting at. What's the value when x is 0? And when we put those two things together, we can write the equation in slope-intercept form, y equals mx plus b. M is our slope. How do we find the slope? Well, there's two common ways that you want to remember. The slope formula. Be able to apply the slope formula when you have two coordinates or when you can find two coordinates from a word problem or a graph or a table of values. All of those representations of the function will lead you to finding two coordinates. So write down your slope formula. You're going to apply that. Y sub 2 minus y sub 1 divided by x sub 2 minus x sub 1 to get the number you plug in for the letter m in y equals mx plus b. Slope is always the coefficient of the x term. It is a number. So let's look at these examples and see how we could compare the slope and the y-intercept. First thing I want to notice about f of x is that f of x, the slope is decreasing because we read a graph from left to right, just like we read a book, right? So if I start from left and I'm looking at these values, the x values are getting bigger because the x values are on the x-axis here and we're going from left to right. As x increases, what's happening to the y values? I'm starting up here at negative 6.5 and then I'm over here at negative 2.3, 0.2. What's happening to the y values as x is getting bigger? Those y values are decreasing. If we were to look at that line and go from left to right, we would see that the line is going down. So we know the slope is negative. That's super important to just be able to look at a graph and know what to expect with the number, the coefficient of the x term. The coefficient of the x term in this example, the slope, is a negative number. Now, how do I find it from a graph? Like I said, we named lots of points here. We could plug into the slope formula, but you don't have to. If you can plot these points, 0, 2, 2, 1, 4, 0, then it's just rise over run. I'm going down 1 and right 2. So that has a slope of negative 1/2. So we already know the equation here because the slope is negative 1/2, y equals negative 1/2 x, And then the y-intercept where it crosses the y-axis is 2, so plus 2. Now we've modeled the equation for f of x. Now let's look at g of x. Al had 2 dozen donuts when he walked into the office. Sure sounds like a y-intercept because that's a starting amount. Let me go ahead and put 2 dozen, 2 times 12, 24. And then every cubicle he passed, he lost 2 donuts. There's my rate of change. How is the starting amount changing? It is decreasing, going down by 2 donuts every 1 cubicle. So that's my slope. And there we have our equation, y equals negative 2x plus 24. And h of x is already given to us in slope-intercept form. And we know the slope here is 6. And the y-intercept, where it crosses the y-axis, is 1. Now, that's different than the other two. The slope here is positive. So that's going to look different because it starts at 1 and goes up by 6 each time. So that's definitely a difference when we're comparing them. They're all linear, but h of x has a positive slope, whereas f of x and g of x both have a negative slope. Now, the y-intercepts we could compare easily. F of x has a y-intercept of 2, g of x has a much greater y-intercept of 24, and h of x has a y-intercept of 1. We could even put them in order from least to greatest if we wanted and say, hey, the lowest one here is going to be h of x. So that's a little information about comparing functions. You always want to start with what we know about the function and how could we model it algebraically using slope-intercept form.